Here at Real Good AI, we've made, well, I'm going to be cavalier and call it a major breakthrough. And so I'm excited to update you on some of the research. So Dr. Eric Bell has been working on putting Gaussian process models in places where there's previously been neural networks. Now, as you may know already, Gaussian process models are interpretable, understandable. They give data attribution, meaning I know why a model picked something because it was pointing at this. It gives you uncertainty quantification, meaning I know when I'm wrong. All good things. And in theory, the computational efficiency will come because you need so much less data for these Gaussian process models. So he's been working on these, and just before you get your pitchforks, this was on a very small application. He just trained it on a gaming rig. It was not a server farm, no data centers, no unfair data was used in the creating. He only used War and Peace, the one book, and tried to train a language model on it. Now, it's just like some of your other languages where you can prompt it with some language and it will talk back to you, but this is like super basic fundamental research just to see things for research only, not for taking over the world or anything else that LLMs are for. So he found something so interesting because he's implemented these Gaussian process models. We get how certain the model is of the things that it's saying, which is just opening up this whole world of cool understanding of what's going on and illuminating the black box, if you will. So, this first step, now I will put the caveats here that the big LLMs that everyone does are trained on so much data, et cetera, et cetera. They might have different conclusions than what we're drawing, but in these small data cases, we are starting to see some trends emerge. And I want to tell you about two of the most interesting ones. Now, the first one is that the more the model talks, the more it tells back to you, the further along in its context window it gets, the less coherent it is. So like if it makes a tiny mistake up front, then it like kind of totally goes off the rails and has no idea what it's talking about. And like even small errors that it makes earlier on in what it's saying can totally derail what it's going to say into not saying anything at all. The second thing, which is so interesting, well, you wouldn't think about this maybe, but these models have to generate spaces because it doesn't know what a word is, and it's like ours is tokenized, which just means it's generating each letter at a time and moving forward onto the next letter. So it's spelling words out. And so after it finishes a word, it's like, yes, that's a word. So here's a space. And it's very sure that it knows that that's going to be a space because it spelled a word. Yay, spaces go after spelling words. But then when it's trying to say the next word, every time there's this like spike in uncertainty because it's like, I don't know what to say next. What should I say next? And then it like guesses a letter and then it spells that word out that it was thinking of, and it gets more certain as it goes along that word. And then it's like, yes, space again. And then it's like, oh God, I have to say another word. What comes next? And it's very uncertain. This is just really interesting because people are ascribing to LLMs all this long-term dependency. And even though we have a lot of the same machine learning, like machinery in the workflow of the transformer, blah, 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 that it's all very similar, except we have a Gaussian process model. It should be similar in what sort of dependencies. Maybe these dependencies need more data to learn. Maybe they're imagined. Maybe it's just so good at understanding local information that it appears to have global coherence. Anyway, I am so excited about this breakthrough. Please congratulate Dr. Eric Bell. This is amazing research, and he's doing the work and having some results so far. So this is very exciting for us. I don't know if you can tell, I'm very excited, but thank you so much for letting us do this. I think it's really important, and we are starting to understand what's going on, at least in these very small cases.